Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on December 1st, 2025, just yesterday. It introduces Envision, a new benchmark and scoring metric that reveals a striking gap between pretty single images and true world understanding, showing that specialized text-to-image models excel at aesthetics but fail at causal, multi-frame reasoning, while unified multimodal systems only partially close that gap. The paper is titled Envision, Benchmarking Unified Understanding and Generation for Causal World Process Insights, and the implications for how we train future vision and language models are quite significant. Also, the author shared a GitHub repo for Envision. There you'll find the benchmark dataset instructions, a git command to grab the prompts and process descriptions, and an eval.py script that runs the full multi-dimensional scoring pipeline on your generated image sequences, plus basic configs, web assets, and leaderboard links. Table 1 spells out how the difficulty of text-to-visual generation ramps up across modalities. The table shows that plain text-to-image only demands good-looking pictures with correct objects and text in the right places. Moving to text-to-multi-image adds chains of events, consistent attributes, and clear event causality. The final step, text-to-video, further requires coherent actions, object and attribute consistency, and smooth temporal continuity across frames. Figure 1 lays out the four-stage roadmap for how generative models could mature from snapshot pattern matchers into genuine world simulators. The bottom band shows semantic anchoring, where the model simply names objects like a lion or a zebra in a static scene. Above that comes spatial deconstruction, which separates different parts of the scene, and temporal weaving, which strings frames into a causal sequence, all culminating in full world simulation at the top. Figure 2 shows how Envision treats multi-image generation as a flexible bridge between video and single images, so it can probe both smooth motion and stepwise events. The top strip illustrates continuous change, where a zebra gradually moves across the savanna and every frame must transition smoothly. The bottom strip illustrates discrete stages of an industrial scene, where frames jump between key moments but still need a coherent causal storyline. So Table 2 makes the performance gap very concrete by comparing Envision scores across science and culture domains. The table shows that closed-source text-to-image models like GPT-4o sit clearly on top overall, with strong scores in physics, biology, and culture. Open-source text-to-image models trail them, especially in physics and meteorology, even when some produce attractive images. Unified multimodal models land in the middle because they encode more world knowledge than pure generators, but still cannot match the best closed systems in strict scientific causality. Figure 6 shows how different model families stack up on consistency, aesthetics, and physicality scores. The yellow closed-source text-to-image models sit clearly at the top across all three panels, which means they best preserve causal stories, visual appeal, and basic physics at the same time. The blue open-source generators reach competitive aesthetic scores, but stay lower on consistency and physicality. The red unified multimodal models generally land in the middle, so they narrow the reasoning gap, but do not yet match the strongest closed systems. Alright, wrapping up, 2 takeaways stand out. Strong single images do not prove real-world understanding, and multi-image causal benchmarks like Envision expose that gap very clearly. The broader message is that future vision language models must be trained to simulate evolving processes, not just match patterns. That is it for this episode of the AI Research Roundup. I'm Alex, thanks for listening.